right, today our topic is something called percent yield. So you've already spent some time talking about limiting reactants, which of course the main goal of limiting reactants is to figure out which reactant runs out first, and that stops your reaction from continuing. Well, another application of limiting reactants is to say, okay, did you produce the amount of product that you were supposed to produce? So the reason that that's useful is that if you are trying to create a useful product, to figure out if you are creating as much as you're supposed to, like if that's part of your job, or if you are trying not to produce something, if maybe there's a harmful byproduct in your reaction, like something that happens even though we don't want it to, it's just part of the reaction, we can be careful about how much we're producing. So that kind of idea is related to percent yield. So to figure out percent yield, which is basically how close were you to creating the calculated amount of product, like how much you were supposed to, you would use this equation. It's percent, so you're going to take the actual amount, what did you actually get, which is from lab, from actually doing it, compared to what you theoretically were supposed to get. So that's just based on math. So what you really got divided on what you were supposed to times 100, because that puts it into percent. And your goal is going to be 100%, because that means the amount you actually made was the exact same as the amount you were supposed to make. So that would be your goal. Percent yield, you're trying to get 100%. Well, in a lab, that doesn't always happen. If the calculated percent is greater than 100, it doesn't mean you got extra credit. You can't get extra credit in a chemical equation. If there was a calculated amount you were supposed to get, that's the maximum amount. So 100% is your highest amount. If you get something higher than 100, it means that your product had something else mixed into it. Your product was not pure. There was something else mixed in. Maybe some of the other product is mixed into it, or maybe there was something that spilled into it or something like that. If you got less than you were supposed to, that means you lost some product somewhere. Lost some product during the procedure. So maybe there was a step where you had to filter and it was stuck in the other container, or it got stuck in the filter paper. Or there was a spill that happened, but something during the procedure caused you to lose some of your product. So 100% is the only perfect answer. Less than or higher than that means there was some sort of lab error. And that's something that you can think about more when you know what your specific procedure is. Let's go ahead and do an example like this. So here would be what a percent yield problem would look like. When you did a lab, you did 23 grams of zinc reacting with 55 grams of oxygen. You put that in a sealed chamber and you produce 23.3 grams of zinc oxide. What is the percent yield of this experiment? Okay, well, really, what is it asking for? Well, if it's asking for percent yield, if that's our goal, that means that we have to be able to do this. The actual yield divided by the theoretical yield. Okay, well, actual is what we did in lab, right? So we know that number. So the actual is my 23.3 grams of zinc. We don't know what we were supposed to get though. So in order to do this, there's a few steps you can kind of think about. So what we need to know is we need to know what our chemical equation actually was. Well, it says that I started with zinc. It says that I started with oxygen. Remember that between these two, zinc is not a diatomic, but oxygen is a diatomic. It says that I produced zinc oxide. All right, well, if you look on your peat sheet, you'll see that zinc is +2. And if you look on your periodic table, you'll see that oxygen, is -2. They are a perfect match, so that means that it is ZnO. However, look at here, we've got 2 oxygens on this side and only 1 on this side, so we got to balance that. Oh, but then that makes there be 2 zinc, so we got to balance that. There's our balanced equation. Now we need to do an LR problem. Now the reason we need to do an LR problem is that we have to figure out how much of my zinc oxide was the maximum amount possible, starting with my 2 givens. I don't know which ran out first. Did the zinc run out or did the oxygen run out? So I have to do 2 problems. This is awesome. It gives us a chance to review stoichiometry. So it doesn't matter which one you start with. We got to do both of them. So let's just go in order. 23 grams of zinc. So let's start with that. So 23 grams of zinc. However, the problem is asking about the theoretical yield of zinc oxide. So we have to do a stoichiometry problem because I'm at zinc and I want zinc oxide. Well, remember, every stoich problem has the switchover step, and the switchover step has to be in moles. So I can't go from grams right to zinc oxide. I have to get from grams of zinc to moles of zinc. That's my next step. Well, we can do that. We can go from grams to moles. That's molar mass. Look, here's zinc. 65.39 is my molar mass. That's the number of grams. Grams is what I want to cancel, so that needs to go down here. So 63 point, what did I say? 63.39, or 60, sorry, 65.39. 65.39 grams of zinc for every 1 mole of zinc. That's the definition of molar mass. Grams of zinc goes away. I'm at moles of zinc, which is good because now I can do the switchover step. So the switchover step says I want to get rid of moles of zinc and switch over to moles of zinc oxide because that's what the problem is asking for. So I know that moles of zinc will be on the bottom, so it cancels. I know that moles of zinc oxide will go on the top because I'm switching to that. The ratio comes from the balanced equation, the coefficients. It's a 2 and a 2. I still have to do that step though because I had to switch chemicals. Now I'm at moles of zinc oxide. Well, I don't want moles of zinc oxide. I have to be able to compare it to grams. So I have one more step. But I can figure this out. I can add them up. I know that, so like got our calculator going here, I know that the molar mass of zinc is 65.39. I know that oxygen's molar mass is 16. And because the formula is just zinc and oxygen, one of each, then it's just 16 plus the zinc 65.39, and that equals 81.39. So using my calculator here, that's the number of grams. So this time, 1 mole of zinc oxide needs to be on the bottom because that's what has to cancel, and then the 81.39 grams goes on top. Moles goes away, I'm left with grams. That's what the problem wanted me to find. It wants me to compare it to this number, grams of zinc oxide. Now I can do my math. So I'm going to take this number times 2 times 1 times 23, because those are all on the top. I'm going to take that divided by 65.39 divided by 2 equals. So 28.63, we'll round that off to 28.63 grams of zinc oxide. Now, remember, we're not quite done. That's the grams of zinc oxide I should produce if I run out of my zinc. But I don't know if I ran out of my zinc. I don't know what the LR is, so we've got to do our second stoich problem. The good news, it's the same steps, only now we're going to start with our 55 grams of oxygen. So 55 grams, remember oxygen is diatomic. So that's where I'm starting. So it's the same steps. I'm trying to get to the switchover step. So I have to go from grams to moles of oxygen first. Well, we know that oxygen is 16, but remember there's 2 of them. So it's going to be 32 grams of oxygen for every 1 mole of oxygen. Grams of oxygen goes away, which is good. Now that I'm at moles of oxygen, I can do my switchover step. So I want moles of oxygen to cancel, so that's going on the bottom. I want to switch to moles of zinc oxide. I'm doing that because that's what the problem is asking for, zinc oxide. The ratio here comes from the balanced equation. 1 goes in front of oxygen because there's no number. 2 goes in front of zinc oxide because that's the coefficient. And then once again, moles of oxygen goes away. So once again, I'm left with moles of zinc oxide, but I don't want moles. I need grams. So I do this same step. But the nice thing is that you don't have to figure it out again. So 81.39 grams for every 1 mole of zinc oxide. So zinc oxide goes away, I'm left with grams. Now I can just solve this problem. So let's clear this out, multiply everything on the top, divide everything on the bottom. So 55 times 1 times 2 times 81.39, and then divide on the bottom. Divided by 32, divided by 1, divided by 1, ends up with this. 279.78, 279.78. And this would be grams of zinc oxide. Okay, so this means that I would make this many grams of zinc oxide if my oxygen was the limiting reactant. But here's the thing, there's no way I can make this many grams of zinc oxide because remember when we made 28.63 grams of zinc oxide, my zinc was gone. So this is the bogus, not possible, never happened answer, which means this is the number that I should be getting. So this is my theoretical. So according to math, I should be getting 28.63, which means that zinc is the LR and oxygen is in excess. Okay, So now that I know that, now I can figure this question. So I said I know my LR, which means I know my theoretical yield, which means now I can do percent yield. Remember, percent yield is the actual amount from lab, the theoretical amount from math, okay? So actual A over T. So the actual I got from this problem. It says 23.3 grams of zinc oxide. So 23.3 grams of zinc oxide is actual, divided by theoretical, which is what I was supposed to get. I was supposed to get 28.63 grams of zinc oxide, okay? It's called percent yield, so we times it by 100. Now I'm ready to get my answer. So now we just got to divide it times by 100. So 23.3 divided by 28.63 times 100, because then that puts it into percent, tells me I got 81.4, move that over there. Oh, I'm out of room. 81.4%. So yield, percent yield, label it percent yield. So this tells me that I didn't get everything I wanted. I must have lost some of my product along the way, but I got quite a bit of it. I got quite a bit of what I was hoping for. So 81.4 percent yield is my answer. So then after that I could make some decision about, well, what happened to the rest of it? So this is percent yield. So the idea here is that you are using what we know about limiting reactant and what we know about theoretical yield to figure out, well, how good did you do? Did you get all of your reactant or product you were supposed to, or did you lose some, or was it impure? But that is percent yield. All right, so now I'd like you to continue on and do some practice with percent yield. So always figuring out your theoretical from math and the actual from lab, actual over theoretical times 100. Goal is 100%, and if it's less than 100, it means you lost some product somewhere. If it's over 100, it means your product was impure. And that, again, you would know more specifically when you looked at your specific lab procedure. All right, thanks for listening.